Good afternoon. Today, I'd like to present an autonomous inspection system for detecting voids in LNG carrier bonding layers. This is a typical membrane type. Uh, yeah. This is a typical membrane type LNG carrier. And inside this LNG carrier, there are four tanks. And the size of each tank is about the half of a soccer field. And then the gas inside the tank is protected by two layers. The first primary layer is made of stainless steel, and then the second barrier is made of composite material called triplex layer. And between them there are polyurethane forms. And this bonding layer is installed by this automatic bonding machine developed by Hyundai Heavy Industries. And then if you look at the thickness of triplex layer is between 1.6 and 2.6 millimeters. And each triplex layer is made of three layers, and often a void is formed inside this bonding layer. And any voids which are larger than 8 millimeters in the transverse direction needs to be detected, and then that part of the triplex layer needs to be replaced. And how they do the inspection right now? Well, literally using a metal stick, they rough the surface. And if there is some internal void, then when you apply the pressure, it's going to create a surface dent. So that's how they do inspection. And as you can imagine, this can be a very time consuming and labor intensive. And not only that, they have to do the same inspection 4 times. First, the inspection is done the shipbuilder, in this case the Hyundai Heavy Industry, and second, it has to be done by the supplier of triplex layers, and third, it has to be done by an independent inspection company, and finally it has to be done by the owner of the ship. Why? Because they don't trust each other. So if something happens, they want to make sure that they can blame the other parties. Okay, that's the reality. So we developed an autonomous inspection system so that we can do a real-time inspection using thermography. Okay, so using our system, we were able to reduce the inspection time and cost more than 80%, 70%. But the actual saving comes from the improved reliability of the inspection. Because if there is any void that we missed, then later on, they have to spend more than $1 million just to replace that part of the triplex layer. Okay, so our system. Let me skip this part. So this is the actual inspection. So this is the surface of the triplex layer. So you don't see much, but if you look at the X-ray image, you can see internal voids. And then using our technique, we can detect all the voids. Okay, so our system is deployed the inspection of the actual LNG carriers. But because of the confidentiality, I'm showing you the results only from a mock-up specimen. Okay, so as we do inspection, we printed out the void information on the surface. so that the workers can easily spot the location of the void. So we are applying the heating and then we are doing real-time inspection. And from the side, you can see the wheels here so that the unit can climb over the side walls as well as the ceiling. Okay? And, and also, we are visualizing the thermal images in real time as well as the final diagnosis results. Okay? So that's the end of my presentation, and I'd like to thank Hyundai Heavy Industries for their financial support and all my students for their hard work. Thank you very much for your attention.